Karthik, and this is a presentation in part of IPv6 presentation series on securitytube.net. In this presentation, I will be talking more about IPv6 address space, how many addresses are possible in IPv6 as compared to IPv4, and how exactly IPv6 is going to solve the IP crunch problem currently faced in IPv4. At the end of this video, I will be also talking about how to write IPv6 addresses and some shorthand representation for IPv6 addresses. To have some comparison factor and some background, let's start with IPv4 address space. In IPv4, the address space was only 32-bit. That is, the source address or destination address can be of maximum size 32 bits. So as we write our standard IPv4 addresses as 192.168.100.1, so the IP address will be written in 0 to 32 bits like this. Now with IPv4, number of possible addresses were 2 to power 32, which is around 4 billion. Our current world population itself is more than 6 billion, so there is not a single address per human being on this earth. Again, only the small fraction of this IPv4 total address space is currently usable due to historic reasons, and even the current address range is not sufficient to serve 20% population of this world. As more and more devices are getting internet connectivity, the number of IP address requirement is going on increasing, and within a couple of years the IP address are going to be exhausted, and we need some more space, some better management of this IP addresses. The 32-bit address limit in IPv4 is being extended to 128 bits in IPv6. So 32-bit correspond to 4 bytes, so 128 bits will correspond to 16 bytes. So the IP address will be written in 16-byte format. So total number of addresses are 2 to power 128, which comes to be such a huge number, gosh. So 6.65 into 10 to power 23 addresses are available per square meter of the earth, or every grain of sand on this earth can be given multiple number of IP addresses. This is mind blowing. Now how to write this IPv6 addresses or the address notation. IPv6 addresses are 128 bits or 16 bytes. So these 16 bytes are divided into 8 16-bit hexadecimal colon separated blocks. So a typical IP address will be something like 2001 colon 0db0 colon 0000 colon 0000 colon 0202 colon 11ff colon fe45 colon 0087. Oh, such a big address. I know it is 128 bits and no one is expected to remember such a big address. Even manual configuration is going to be difficult, and to solve this problem, the auto configuration, stateless auto configuration is being introduced in IPv6. I have created separate videos on stateless auto configuration. That's not the thing which we want to discuss now. How to abbreviate this address? Is it possible to abbreviate? Yes. The leading zeros can be replaced with single zero and they can be skipped. So the address can be simply written as 2001 colon db0 colon 0 colon 0 colon 202 colon 11ff colon fe45 colon 87. So all the leading zeros like here, these in between zeros are just replaced with single zero. One more step of abbreviation can be done, and which is double colons can replace consecutive zeros. Here there are consecutive zeros, so these two consecutive zeros can be simply replaced with double colon, and the address will look like 2001 colon db0 colon colon 202 colon 11ff colon fe45 colon 87. So these double colons will be expanded with number of zeros required to fulfill 128-bit limit. Very important note to be made here: the leading zeros can be replaced with double colon only once in an address. So if the address is 2001 colon db8 colon 00 colon 0056 colon 0000 colon abcd colon ef12 colon 1234, either first zero or these block of second zeros can be replaced with double colons. And why so? Because while sending actual packets, all these double colons have to be replaced by zeros by the computer, and the computer will not be able to know which double colons have to be replaced with how many zeros, because if there are multiple double colons it will be a confusion. So to avoid that, only single double colon is possible in any IP address. So this same IP address can be written by replacing all these leading zeros with single zero. Either leading zeros can be replaced with single zeros. The first and second address are perfectly valid. The third address, the first zero is being replaced with double colon, so the address has become 2001 colon db8 colon 56 colon 0000 colon abcd colon ef12 colon 1234. This is perfectly valid address. Even these 4 zeros can be replaced with a single zero. That is also a valid address. The fourth IP address is also a valid address. In this, the second leading zeros, all these 4 zeros have been replaced. All these 4 zeros have been replaced with colon colon, and these zeros are being shown here. I can even write a single zero here, which is again a valid thing. So the address is 2001 colon db8 colon 0 colon 56 colon abcd colon ef12 and so on. The last IP address is though invalid, because here I have replaced first block of zeros with colon colon as well as second block of zeros with colon colon. So in single IP address I cannot have multiple double colons. So last IP address is perfectly invalid. That's it for this video. Keep on watching more IPv6 and other network security related videos on securitytube.net. Thank you.